When a hyperbola center 0, 0 is translated horizontally by h units horizontally, vertically by k units, the center of the hyperbola moves from 0, 0 to hk, just like in parabolas, just like in ellipses. Such a translation does not change the length of the transverse or conjugate axis or the Pythagorean relation. Everything is pretty much the same. Now, find an equation in standard form for the hyperbola that satisfies the given conditions. Now, it does say the transverse axis endpoints are -2, -1, and 8, -1. Because transverse axis is just like major axis of an ellipse, that means that is A. So 2A is equal to 10 because the distance between -2 and 8 is 10. That means A is 5. Conjugate axis length is 8. That means 2B is 8. That means B is 4. Now your center of this ellipse will be the midway point between -2, -1 and 8, -1. Well, halfway between -2 and 8 is +3, and they're both -1, so we're going to keep that there. So that's your midpoint. So now we pretty much have everything we need. The only thing is you got to decide what equation you want to use. Well, because it is -2 and 8 here, we want to look at our chart. Which one changes here? Well, it's going to be the h plus or minus a, so we're going to use this equation for part A. Now when you put this in, x minus 3 squared over a squared, which is 25, minus y plus 1 squared over b squared, which is 16, and that will equal 1. So there's your equation for 3a. Now for b, it says the transverse axis endpoints are 2, 3, and 2, -1. That means 2a will equal 4, a will equal 2, conjugate axis length is 6, that means 2b will equal 6, b will equal 3. Our center is the midpoint between 2, 3, and 2, -1. Well, it's going to be 2 here. Halfway between 3 and -1 would be 1. So there's your center. Now again, because the y values change here, we're going to go up to our chart and notice that the y values change here. So we're going to use the second one for part B. So we'll have y minus 1 squared over a squared minus x minus 2 squared over b squared. So there's your equation. Now in example 4, we'll be locating key points of the hyperbola. So we're going to find the center vertices and foci of the hyperbola. Now again, a squared is always first, so a squared is 9. That means a is 3. B squared is 49. That means b is 7. And then also we need to find c squared. So c squared is equal to a squared plus b squared, which means c will be the square root of 9 plus 49, which is the square root of 58. We should be able to pick out our center by now. Our center, the x value, take the opposite of x, the opposite of y. There's our center. Our vertices, because x squared is over a squared, our vertices will be h plus or minus a, so -2 plus 3, -2 plus 3 is 1, 5, and then -2 minus 3. There are our vertices. Our foci, the h plus or minus c, k. So we'll have h, which is negative 2 plus the square root of 58. So there's our foci right there. Now, if we put these into our calculator, we'll get a decimal value. .62, and then negative 2 minus the square root of 58, negative 9.62. So this will really be 5.62, 5, and negative 9.625, if you want decimal values for those. Moving on to B, our A value, or A squared is 12. That means A will equal the square root of 12. B squared is 13. That means B will equal the square root of 13. C squared will equal A squared plus B squared, so 12 plus 13, which is a square root of 25, which is 5. Now you should be able to pick out your center by now. Opposite of x, opposite of y. Your vertices, it'll be h plus or minus a. Okay, because x squared comes before y squared here. So we'll have negative 4 plus the square root of 12, negative 6. Negative 4 minus the square root of 12, negative 6. Put that in our calculator. We'll have negative 0.54. And also negative 7.46. So there's your vertices. Your foci will be h plus or minus ck. So that will be negative 4 plus 5, which is 1, and negative 4 minus 5, which is negative 9. So there are your center, your vertices, and your foci.